Hello friends, welcome to Joy of Life. So today we are going to look at another medium level problem from Leetcode. The problem number is 1302, deepest leaf sum. So the problem says given the root of a binary tree, return the sum of the values of its deepest level. Okay, so here we are given with a tree that you can see that it has many levels starting from say level 1, then level 2, level 3, level 4, and each of the level you can have a sum of all the nodes. So in the level 2, so this, let's say this is level 1, this is level 2, this is 3, this is 4. So at level 2 we can see the sum is 5. At level 3 the sum is 15. So we are adding all this up, and at level 4 we have a sum which is again 15. So we have to find the sum of the deepest level. So the deepest level being the one that is present here. So we have to return the sum of all the nodes in this level. So to give it a try, it's not a very difficult problem. We have discussed similar kind of problems in this channel previously. Do give it a try, and then you can continue watching my video. So what I have done is I have taken the same tree from the lead code example, and we are going to use the same tree in order to come up with the solution. So basically, if you see the problem, what it says that the deepest level. So a very important hint is lying over there. That is the word level. So when we get such word for a particular level, what strikes to my mind is something like a level order traversal, right? Because we are talking about the sum at every level, right? So we can do a level order traversal, and it so what we're going to basically do is at every level we are going to find out the sum for each of the levels. So we traverse level by level, right? So when we go to the next level, what we are going to do is we are going to reset the sum to 0 and do the sum all over again. So when we exit out of our loop, what we are going to have the sum of the last level. So let's see how we are going to do it. So basically this is a very easy problem. So we are going to maintain a queue, right? So queue is a data structure wherein we have a first in first out. So let's put a queue over here and see how we are going to use that queue in order to come up with the solution. So let's say this is our queue over here, and you know that queue one end we put things, so we enqueue from one end and we dequeue things from the other end. We take out the things from this end. So whatever goes in first comes out first. So it's a FIFO data structure, right, as we know, and it's a queue. So what we are going to do is we are going to put down our algorithm over here on the right hand side, and we are going to see how what we are going to do over here. We are going to queue dot put, we are going to put the root of the tree. So we are going to put 1 to the tree. So what happened? 1 comes over here, right? And then we start a loop. So we are going to say loop until queue is empty. Okay, so just remember we have one element inside the queue, and as I have already discussed in the earlier videos as well. So at this point when we get the size of the queue, so it is going to tell me how many elements belong to this level. So in this case, when I do a size, what I'll get is a 1, right? And what we are going to do is we are going to iterate. So we are going to iterate 0 to size. So our iteration starts from 0 and ends at 1. Because there are only one element, I'm going to take that out and consider that element is belonging to this level. Okay, and since we are talking about a sum over here, so let us put a sum over here, and let's say the sum is equals to 0. So let's maintain the sum in our try run example over here. So sum is currently at 0. So what we are going to do before we start to iterate every time, we are going to reinitialize this sum to 0. So let me get some space over here. So we are going to sum is equals to 0. And in a level order traversal, what we generally do, we go and we add the left and the right child for each and every node. So what we are going to do is, so we generally do a queue.poll and store the element in E. So as soon as we do a E.poll, what's going to happen is 1 is going to get popped out, right? So this is popped out, and we get the 1 inside the variable E. In the queue is we'll be adding, so what we'll be doing is we'll be adding the left child and right child for the queue. So E.left will add, of course we'll do a null check in real time scenario, but here I'm not doing for simplicity purpose. So we are going to add E.left. Okay, so E is a class which is denoted by this class over here, and the element is called val, VAL. So we are going to do the same thing over here. So what we are going to do is we are going to sum it up. So we are going to say sum equals to sum plus e dot val. So what is going to happen? E dot val is the value 1 that we have seen over here, that we have taken out the value 1. So we are going to do a 0 plus 1, and we have a sum which is 1. So now what will happen due to these two statement over here, q dot add left and right. So as you see that we have the tree over here, let me get some space. So we are going to add the left and the right child for this queue. So we are going to add 2 and 3 into the queue, right? So let me put it with a different color over here. So we are going to add 2 and 3 into the queue. So this loop over here terminates because the size was previously 1, right? And it goes again to the top and it checks that if the queue is empty. No, the queue isn't empty, right, at this point of time. So what happens is it gets the size all over again. So let me remove all these things. So this time it gets a size which is 2, right? So this loop over here, it will go for 2 times now. So it will do a e dot poll, which will remove 2 from the queue, right? And what will happen is, so remember when we went to the top, we have removed this, resetted the sum to 0, right? Before we got this, after we got the size. So what happened is we are doing a sum. So we are doing a 0 plus 2 and putting a new value of 2 over here. And we are adding 2's left child and right child. So 4 and 5 will be added over here. Okay, so it is done. So this loop has executed one time and it has taken out 2. Now it will iterate once more because the size is 2, and this time we are going to pop out 3 from the queue. So what we are going to do is we are going to do a sum equals to sum plus e dot val. E dot val is 3 this time. So 2 plus 3 will be putting a 5 in the sum, right? And then we'll be adding the left and right child of 3. But 3 doesn't have a left child, so it has only a right child. So we put only 6 inside. So this loop over here, this loop terminates because it has iterated twice. So it goes up again, and now we fetch the size, and what we get, the size is a 3 this time because there are 3 elements inside the queue. So we get a 3 over here, and we reset the sum back to 0, right? Because a new level is beginning again. And what happens over here is this loop will now go for 0 to 3 times. So first we do a poll, we get a 4. So what we do is we do a 0 plus 4 and update the value 4 over here. Okay, so what we do, we add um, 4's left child and right child. So we put a 7 in the queue. 4 doesn't have a right child. So this loop has executed one time. Now it will go for the second time and it will get a 5 out of the queue. So we'll do a 4 plus 5, and what we'll be putting is a 9 inside the queue, inside the variable sum. And we'll be adding 5's left child and right child, but 5 doesn't have a left child or a right child. So this loop is done iterating 2 times. One time is remaining because we're going to do it for 3 times. So we do a poll again, we get a 6. So we do a 9 plus 6 and we have a 15 now in the sum. And this loop terminates and we go back all over to the top again to check if the queue is empty, but the queue is not empty. So what we are going to do is we are going to get its size. So this time when I get the size, the value I get is a okay. So for 6 we have to add the child. I didn't add it, sorry. Okay, so we get the size 2, and we reset the sum back to 0. And what we do is over here is we start iterating this loop 0 to 2 times. So this loop will go on for 2 times now. So it does a poll and it gets a 7. So sum equals to 0 plus 7, which is a 7. So we'll put 7 over here. And there are no childs for 7, right? 7 is the leaf node, so nothing to add. So this loop will go on one more time. So this time what I get is a 8. So we do a 7 plus 8 and we put a 15 inside the sum. And again, 8 is a leaf node which doesn't have a child, so we are not adding anything. So we go down to the top and we see that the queue is empty. So there is nothing more to iterate in this queue. So what do? We just go back and return the sum. What does the sum contain? Sum contains the sum of all the nodes in the very last level, because we have done a level order traversal. And do remember that this time it failed to enter this loop, right? Because this condition was not met. So sum was never resetted back to 0 and we return the sum, right? This is a very basic solution. So what we're going to do is we're going to quickly jump over to Leetcode and write down the code for this. It's going to be very straightforward as we have done earlier as well. So let's head over to Leetcode and write down the code. The first thing that we need is a queue, and we are going to store the nodes in that. So we'll be putting the tree nodes inside it, and let's call it Q and let it be a linked list implementation. Okay, and we also need a sum which will be initialized to 0 and which will be returned back at the end of our traversal, right? So what we are going to do next is we are going to add the root of the street to the queue, and we are going to iterate until the queue is not empty, right? So now what we're going to do is first thing we need is the size of the queue. So we are going to do a queue dot size and we'll get the size and we'll reset the sum back to 0 again. So for first time it doesn't matter, but for subsequent times we have to reset it back to 0, right? So that's what we are doing over here. And then we are going to have a very simple for loop which will start from 0 and which will be less than the size and will be iterating I at every moment. First we have to get the tree node and let's call it node, and we are going to do a queue.poll. So queue.poll will give me the element from the top of the queue. We are going to update sum. So we are going to do sum equals to sum plus node.val. And then we are going to add the left and the right child. So to do that, the thing that we haven't done over there is we have to do a null check because we don't be putting nulls, right? So we are going to do a null check, and after checking, we are going to do the add. So we are going to put node left and node right. Another similar check for the right node also. It should not be equals to null, and we are going to do a add of node dot right. And at the end, when we come out of this loop, we are already returning the sum, right? So the solution is pretty much it as you see on the screen. That's going to be a very simple solution if I have not made any mistakes over here. So let's run and check how it goes. So yeah, it's fine for me. So let's submit and check. Well, it has been accepted with 3 milliseconds, which is faster than 50% of the submission. So once again, the main intention was to give you the idea. So the idea was pretty simple over here. So we are just doing a level order traversal in order to come up with the solution. So I hope this solution was helpful to you. Do let me know what you think about the solution. And this was a very simple problem. So I'll be doing more problems in the days to come. But do let me know what you think about the solution. If you have any suggestion for me, do let me know. If you want me to solve any particular problem from any platform, you can specify the number, though I don't have the premium access to most of to none of the platform actually, to be honest. So but you can share the problems with me. I can solve them and create videos like this which has all the possible details so that you have a good learning and understanding from the problem. Do let me know how I can improve the videos. So I have been recently doing some experiment with the light setup, with the camera setup. So today this video with a transparent background was an experiment. I don't know how it is. I have seen many of my favorite gamers use it, but I thought of trying that as well. And I feel, yeah, I could save a lot of space and could be more interactive also. And the video also I don't know how it looks. I would leave up to you guys to give me the feedback on this. So thank you once again and have a great day. See you guys soon. Bye bye.